Hi guys, one last set of videos for today, and we're going to get into extraneous solutions and multiple radical signs. Okay, how do we deal with something like what we see here? So here's the deal. I have radical sign on both sides, and we said earlier in the example problems that only had one radical sign, that we needed to get that radical by itself before we could do any squaring, right, to get rid of it. Well, in this case, it's easy to actually make this problem more complicated than it actually is. What we want to do is we just want to see what happens if I go through and I just square both sides. Because what I'm doing, in essence, is I'm saying if I square the left side and square the right side, the square and the square root go away in both cases, and I'm just left with x plus 3 equals 4x minus 8. Holy moly, that actually seems really easy, right? So I'm going to combine like terms here. I'm going to subtract x from both sides. Okay, that gives me 3 is equal to 3x minus 8. And then I'm going to add the 8 over here, move it over to the left-hand side, and I get 11, right? 3x is equal to 11. Now, if I divide both sides by 3, that gives me x is equal to 11 over 3, okay? Seems weird, but that's the answer. So let's go through and let's check and make sure that that's okay. If I go to the original equation, the equation is, listen, if I take 11 thirds plus 3 and I square root it, is that the same thing as square rooting 4 times 11 thirds minus 8. Okay? Oh, need to move it up a little bit. Okay? So if I take 3 plus 11 thirds, that's 6 and 2 thirds, it looks like, right? That's the square root of 6 and 2 thirds, or 6.7 repeating, 6.6 repeating, excuse me. If I take 4 times 11 thirds, and then I subtract 8, that gives me 6.672. How about that? So this is 6 and 2 thirds, and we know that the square root of 6 and 2 thirds is equal to the square root of 6 and 2 thirds, so everything is good there. That's the answer. 11 thirds is an answer, and it works out. But then we get to a situation like this one. See, I only have one square root sign, and everything is away from it, and I can't combine like terms here, right? I can't add the x and the 3 together. So I've got the radical sign by itself, just like I've been talking about, and we need to do every time, and we're ready to square, but that means we need to square the left-hand side as well. And here's the kicker. The right side is just the 10x plus 9. That's easy enough. We've done that enough times. But the left side, it really turns into a FOIL problem, because I'm saying I'm going to take the x plus 3, that entire side, and I'm going to multiply it by itself. So this becomes a FOIL problem, and if I FOIL that out, that I get x squared plus 3x plus another 3x plus 9, that's equal to 10x plus 9. And I don't have any radical signs, but now I see an x squared, and I'm sitting here going, oh man, that's a quadratic equation problem, isn't it? So let's go through and let's just combine like terms. Let's see what we have. Let's move everything over here. That would be x squared plus 6x plus 9 equals 10x plus 9. Let's move the 10x over, subtract it from both sides. And let's also get rid of the 9's, because they cancel out, right? So x squared minus 4x is equal to 0. That's what I end up with if I subtracted the 10x from both sides. So how do I solve this? I think the easiest way to do this would just be to factor. If I pull out an x, I get x times x minus 4 is equal to 0. Two things multiplied to give me 0 means that either the x is 0 or x minus 4 is equal to 0. So my two solutions, x is either 0 or 4. That's what I'm going for. But I need to check here and make sure that everything works out. Okay, so here I'm going to go up here. I'm going to go, okay, if I put a 0 in, is 0 plus 3 really equal to the square root of 10 times 0 plus 9? I check that, and I say 3 on the left-hand side, and the right-hand side there is no 10, it's just the square root of 9. Is 3 the square root of 9? Yes, indeed it is, so that one works out. Let's try 4. Son of a gun. This is going to work out for both of them. So this doesn't do what I needed to do, okay? But if I check 4, is 4 plus 3 equal to the square root of 10 times 4 plus 9? 4 plus 3 is 7. Is that the square root of 40 plus 9? Yes, it is. 7 is equal to 7, so everything checks out. The problem is that every once in a while, and I guess I didn't pick good example problems because there are no extraneous solutions, but every once in a while you're going to get something where I go plug in a 0 in and they don't equal each other. Like maybe I would get a positive 3 and a negative 3 or something. And what happens in that situation is you actually have to cross that solution off the list. It's something that looks like a solution when you go through and you solve. So it's a solution of this equation, but it's not a solution of the original equation. And I'll show you another method for actually finding that using your graphing calculator later on. But for now, just be aware that whenever you go and check your solutions, there will be times whenever the solutions actually don't match up. You might even get a no solution for an answer to a problem. So hopefully that makes a little bit of sense. We'll get a chance to practice it in class, so I guess I'm not really worried about having bad examples here in your notes.